Let's have a look at a few examples of how we can use this method of integration by parts in slightly unusual situations. All right. Well, what you see in front of you is a typical integral that calls for the integration by parts. Why? Because it's made up of a product. Not only that, but it's a product of two fairly different types of functions. We have an exponential times a trigonometric function. And that means that if we are going to try any change of variable, probably it's not going to work, because whatever is going to make the exponential easier will make the cosine more complicated, and the other way around. So let's try integration by parts, and let's choose. What are we going to choose? Tough to say. So let's make a choice, right? So we have those two pieces. We have to figure out which one is f prime, which one is g. Well, let's use cosine x as f prime and e to the 2x as g. Again, as an exercise, after you have seen how I'm doing it with this choice, you may want to do it with the other choice. So by using e to the 2x as f prime and g as cosine. Notice that both of these functions are easy to integrate and easy to differentiate. Okay? So with my choice, what is f of x? Well, of course, is sine x. Sine x is an antiderivative of cosine x, and the derivative of e to the 2x is 2e to the 2x. So we're going to apply our formula, and that means that our original integral is going to be equal to the product of f and g, which is e to the 2x sine x, minus the product of the two new functions, so e to the 2x times sine x. Well, looks like this thing has not gotten any easier. But notice that it's not any more complicated either. It's pretty much, we now have to deal with an integral which has the same level of difficulty as the original. So what we're going to do is we're going to try again. This time we're going to use those two pieces as the f prime and g, and we're going to keep consistent with our choice. So what we're going to do is we're going to use as f prime the trig part, and as my rg the exponential part. And we go through the steps again. If I'm going too fast, so just pause me. One great thing about these videos, you can pause me anytime you want. You have me under your control. So these are the new functions that we're going to have to deal with. So f is the antiderivative of sine x, which is negative cosine x, and the derivative of e to the 2x is again 2e to the 2x. So let's see what happens now. All right, so our good old integral that we begun with is going to be equal to the e to the 2x sine x, which we're not touching, minus 2 times the new integral, which is now the product of f and g, which is minus e to the 2x cosine x plus twice e to the 2x cosine x, which is the product of the two new functions. Why plus? Well, remember there is a minus in the formula for integration by parts, and there was a minus in one of the two pieces, namely the minus cosine x, and the two together ended up creating the plus. Again, are we running in circles? Notice that we're back to the original integral that we had to begin with. Turns out we are not. All right. All we have to do here is we have to rearrange this equation. Notice that we have the same integral on the left and the right side. We can put them together. So what we're going to do is we're going to rewrite the expression. First of all, we're going to take away all the brackets. So that's what we did. Check that all the brackets were taken away properly with all the minuses taken care of properly. And now we have the same integral on the left and the right hand side. So we're going to move the integral from the right hand side, which was multiplied by -4. We're going to move it to the left hand side. That will give us 5 copies of that integral, equal to whatever we're left with on the other side. And now we're practically done. All we have to do is divide by 5. So the antiderivative, or the indefinite integral of our original question, is going to be given by that particular function that you see there. Right? What are we forgetting once again? The plus c, of course. Now, up to this point, we did not have to put the plus c because we're still hanging out with an indefinite integral, but at this point, we have isolated one antiderivative, so we have to make sure that we add the plus c. So as you can see, sometimes this method of integration by parts requires a little bit of perseverance. The first time may not work. You may need to try it again, and you need to keep your eyes open for opportunities to combine integrals in order to get your answer.